Hi students, we are continuing the course of lecture of hygiene. Today we have a last seventh lecture on the subject of general hygiene. The lecture will read I, Baxışlı Fərəh, head teacher of Department of General Hygiene and Ecology. The topic of today's lecture you can see on the screen. Hygienic characteristic of working conditions as a stage of technological process of preparation of different pharmaceutical forms. Hygienic requirements for planting, equipment, and improvement of pharmacy, control and analytic laboratories. Hygienic factors of working conditions of pharmacists and employers of control and analytic laboratories. Sanitary and educational work in pharmacies and pharmaceutical institutions. What is the pharmaceutical industry? Pharmaceutical industry, one of the leading sectors of the economy. It includes a range of industries which, along with chemical materials processing method, commonly used biological synthesis of pharmaceuticals. Pharmaceutical industry is an important component of healthcare systems throughout the world. It is comprised of many public and private organizations that discover, develop, manufacture, and market medicines for human and animal health. The pharmaceutical industry is based primarily upon the scientific research and development of medicine that prevent or treat disease and disorders. Drug substances exhibit a wide range of pharmacological activity and toxicological properties. Modern scientific and technological advances are accelerating the discovery and development of innovative pharmaceuticals with improved therapeutic activity and reduced side effects. Molecular biologists, medicinal chemists, and pharmacists are improving the benefits of drugs through increased potency and specificity. These advances create new concerns for protecting the health and safety of workers within the pharmaceutical industry. The modern clinical pharmaceutical industry has a number of features. Firstly, is high requirements for chemical purity of products. Next, the for preparation intended for subcutaneous, intramuscular, and intravenous infusions provide complete sterility. A small amount of production of mass drugs, except for sulfonamides, salicylates, analgesics, some antibiotics, and anti-tuberculosis drugs. High consumption of raw materials and characterized by a relatively rapid update of the nomenclature of medicine. Many dynamic scientific, social, and economic factors affect the pharmaceutical industry. Some pharmaceutical companies operate in both national and multinational markets. Therefore, their activities are subject to legislation, regulation, and policies relating to drug development and approval, manufacturing and quality control, marketing and sales. Academic, government, and industry scientists, practicing physicians and pharmacists, as well as the public, influence the pharmaceutical industry. Healthcare productions providers, physicians, dentists, nurses, pharmacists, in hospital, clinic, pharmacies, and private practice. Many prescribe drugs or recommended how they should be dispensed. Government regulation and health care policies on pharmaceuticals are influenced by the public advocacy groups and private interest. These complex factors interact to influence the discovery and development, manufacturing, marketing, and sales of drugs. On this slide, you can see enterprises of the chemical and pharmaceutical industry. Plants for the manufacture of synthesis drugs, of synthetic drugs, plants for the production of antibiotics, enterprises producing preparation and really ready-made dosage forms, plants for the production of galenic pharmaceutical dosage forms. The pharmaceutical industry is largely driven by scientific discovery and development in conjunction with toxicological and clinical experience. You can see on the slides. Minor difference exists between large organizations which engage in a broad range of drug discovery and development, manufacturing and quality control, marketing and sales, and smaller organizations which focus on a specific aspect. Most multinational pharmaceutical companies are involved in these activities. However, they may specialize in one aspect based upon local market factors. Academic, public, and private organizations perform scientific research to discover and develop new drugs. The biotechnology industry is becoming a major contributor to innovative pharmaceutical research. Often, collaborative agreements between research organizations and large pharmaceutical companies are formed to explore the potential of new drug substances. On this slide, you can see technological operation, and technological operations are divided into preparatory, own processes of obtaining medicine, final, and additional. Preparatory operation includes storage, transportation of solid, liquid, and gaseous materials, their transformation, grinding and crushing of solid raw materials, separation of solids, removal of liquids and gases from them using sedimentation, filtration, centrifugation, cooling, crystallization, vaccination method, etc. Professional hazards include dust, intense noise, and total vibration. There are many dust classification. Firstly, according to kinds, natural and artificial. The second, the chemical structure, according to some chemical structure, is organic, inorganic, and mixed. According to dispersion, we'll say about visible more than 10 microns, macroscopical from 0.25 to 10 microns, and ultramicroscopical less than 0.25 microns. And according to dust lesions, we will say about specific like pneumoconiosis, allergic diseases, and non-specific like bronchitis, tracheitis, pneumonias, conjunctivitis, dermatitis. The solid substance suspended in atmospheric air are a dust of natural and artificial case. The natural dust as following is cosmic, volcanic, sea, forest fires, and soil have the greatest hygienic meaning. Natural dust consists of soil, dust of plants, dust. The 70 up to 80% of soil dust of the populated areas located in desert and semi-desert are mineral compounds with a high concentration of 3-silicon dioxide. But the changes of silicosis cars are slender. The plant's dust is a pollen of flowering plants, mushrooms, spores, and bacteria. The dust of artificial origin into air variety in the form of ash and carbon back. The dust can have direct and indirect adverse effects on the people. Exactly in have very big meaning in pharmaceutical industry. Intense noise. Noise is a combination of sounds of various frequency and intensity. Sounds the mechanical vibration of the resonance medium. Its frequency from 60 Hz up to 20,000 Hz. But usually noise is injurious external factor, especially in big cities, in pharmaceutical industry. In workplace, the noise level depends. The first is the distance between the worker and the noise source, time of noise affecting during workday, kind of work, intensity of the noise, and another external factor as air pollution in pharmaceutical premises, in other premises, etc. Clinical presentation of noise effects on organism are differential as specific, like hearing change, and non-specific, change of other organs and systems. What is the specific change? Results of noise, effects of hearing function, is the development of the occupational bradycardia and deafness. At the beginning of noise affects the hearing perceptibility, decrease may be observed. If the hearing perceptibility decrease no more than 10-50 decibel and hearing is restored during 2-3 minutes, it is a temporary physiological adaptation. It is called hearing adaptation. However, when the effects of noise is prolonged, the adaptation ability is exhausted. Also, the period of restoration becomes longer. It is an evidence of hearing function fatigue. When the chronic fatigue is transformed to the occupational bradycardia and deafness. The cause of permanent hearing disorders is an impairment of sound perceiving apparatus of hearing organ, degenerative change in hair cells of spiral organ. But non-specific change is the next clinical presentation of next effect, nose and cardiovascular disorders, central nervous system disorders like rapid forgetability, weakening of memory, decrease of attention, respiratory system disorders like respiration rate and intensity, vestibular apparatus disorders like giddiness, unsteadiness, and etc., endocrine gland disorders, and etc. All processes of obtaining medicines. The basis is the exchange, thermal, electrochemical, biological processes, electrolysis, etc. In this stage of the process, the sulfonation, nitration, and halogenation reactions, amination and oxidation, reduction and oxidation reaction are widely used, etc. The main harmful factor in the reactor compartment is a chemical as well as the unfavorable microclimate. Temperature rise, maybe humidity, high or low humidity, etc. Many different biological and chemical agents are discovered, developed, and used in the pharmaceutical industry. Some manufacturing processes in the pharmaceutical, biochemical, and synthetic organic chemical industries are similar. However, the greater diversity, a smaller scale, and specific application in the pharmaceutical industry are unique. Since the primary purpose is to produce medicinal substances with pharmacological activity, many agents in pharmaceutical research and development and manufacturing are hazardous to workers. Proper control measures must be implemented to protect workers from industrial, clinical, and drug substances during many research and development, manufacturing and quality control operation, and etc. The pharmaceutical industry uses biological agents, bacteria, viruses, in many special applications, such as vaccine production, fermentation processes, derivation of blood-based products, and biotechnology. Biological agents are not addressed by this profile due to their unique pharmaceutical application, but other references are readily available. Chemical agents may be categorized as industrial cleaning chemicals and drug-related substances. They may be raw material, intermediates, or finished products. Special situations arise when industrial chemicals or drug substances are employed in laboratory research and development, quality assurance and control assays, engineering and maintenance, or then they are created as byproducts of roasters. Industrial chemicals are used in researching and development active drug substances and manufacturing, bulk substances and finished pharmaceutical products. Organic and non-organic, inorganic chemicals are raw materials serving as reactants, reagents, catalysts, and solvents. The use of industrial chemicals is determined by the specific manufacturing process and operation. Many of these materials may be hazardous to workers, since worker exposure to industrial chemicals by maybe hazardous occupational exposure limits, such as threshold limits value, have been established by government, technical, and professional organizations. Worker safety hazards may be posed by moving machine parts and equipment, high pressure stream, hot water, reheated surfaces, and hot workplace environments. Corrosive and irritating chemicals, heavy manual handling of materials and equipment, and high noise level. Worker exposure to solvent vapors may occur when recovering or isolating products. Work exposure to solvents may result from uncontained filtration equipment and fugitive emissions for leaking pumps, valves, and manifold stations during extraction and purification steps. Since the isolation and growth of microorganisms and essential for fermentation, biological hazards are reduced by employing non-pathogenic microbes, maintaining closed process equipment, and treating spent broth before its discharge. Generally, process safety concerns are less important during fermentation than during organic synthesis operation, since fermentation is primarily based upon aqueous chemistry and rigorous process containment during seed preparation and fermentation. Fire and explosion hazards may arise during solvent extractions. However, the flammability of solvents is reduced by dilution with water infiltration and recovery steps. Safety hazards, thermal burns, and scaling are posed by the large volumes of pressurized streams and hot water associated with fermentation operation. Chemical synthesis processes are organic and inorganic chemicals in batch operation to produce drug substance with unique physical and pharmacological properties. Typically, a series of chemical reactions are performed in multi-purpose reactions, and the products are isolated by extraction, crystallization, and filtration. The finished products are usually dried, milled, and blended. Organic synthesis plants, process equipment, and utilities are comparable in the pharmaceutical and fine chemical industries. A schematic diagram of an organic synthesis process is given in this table, in this figure. You can see on the slides on screen the diagram of an organic synthesis processes. Pharmaceutical chemistry is becoming increasingly complex. This multi-step processing, where the product from the step becomes a starting material for the next step, until the finished drug product is synthesized. Bulk chemicals, which are intermediate of the finished products, may be transferred between organic synthesis plants for various technical, financial, and legal consideration. Most intermediates and products are produced in a series of batch reactions on a compare basis. Manufacture processes operate for discrete periods of time before material, equipment, and utilities and change to prepare for a new process. Many organic synthesis plants in the pharmaceutical industry are designed to maximize the operating flexibility due to the diversity and complexity of modern medicinal chemistry. This is achieved by construction facilities and installing process equipment that can be modified for new manufacturing processes in addition to via utility requirements. Multi-purpose reactors are the primary processing equipment in chemical synthesis operation. They are reinforced pressure vessels with stainless, glass, or metal alloys linings. The nature of chemical reaction and physical properties of material. You can see on this figure diagram of a chemical reactor in organic synthesis. The nature of chemical reactions and physical properties of material, like reactive, corrosive, flammable, determine the design, features, and construction of reactors. Temperature, pressure, and weight sensing instruments are installed to measure and control the chemical process in the reactors. Reactors may be operated at high pressures or low vacuums, depending upon their engineering designs and features and the requirements of the process chemistry. Heat exchange are connected to reactors to heat or cool the reaction and condense solvent vapors. Then they are heated above the boiling point, created reflux or recycling of the constituent vapors. Air pollution control can be connected to the exhaust vent on process vessels, reducing gas, vapor, and dust emission. Bulk chemical production are recovered or isolated by separation, purification, and filtration operation. Typically, these processes are contained in mother liquors as dissolved or suspended solid as a solvent in a solvent mixture. Many workers' health and safety hazards are posed by synthesis operation. They include safety hazards from moving machine pads, pressurized equipment and pipes, heavy natural handling of material and equipment, steam, hot liquids, heated surface and hot workplace environment, confined space and hazardous energy source like electricity, and high noise levels. Acute and chronic health risk may result from worker exposure to hazardous chemicals during synthesis operation. Chemicals with acute health effects can damage the eyes and skin, be corrosive or irritating to body tissues, cause sensation or allergic reaction, or be asphyxiant, causing suffocation of oxygen deficiency. Chemicals with chronic health effects may cause cancer or damage the liver, kidneys, or lungs, or affect the nervous, endocrine, reproductive, or other organ system. Health and safety hazards may be controlled by implement appropriate control measures like process modification, engineering control, administrative practices, personal and respiratory protective equipment. Organic synthesis reaction may create mere process safety risks from highly hazardous material, fire, explosion of uncontrolled chemical reaction, which impact of the community surrounding the plant. Process safety can be very complex in organic synthesis. It is addressed in several ways by examining the dynamics of chemical reaction, properties of highly hazardous materials, design, operation, and maintenance of equipment and utilities, training of operating and engineering staff, and emergency preparedness and response of the facility and local community. Technical guidance is available on process hazard analysis and management activities to reduce the risk of chemical synthesis operation. Large volumes of natural materials such as plant and animal matter may be processed to extract substances which are pharmacologically active, In each step of this process, the volumes of materials are reduced by a series of batch processes until the final drug products is obtained. Typically, processes are performed in compared lasting a few weeks until the desired quantity of finished products is obtained. Some workers may develop allergic and or skin irritation from handling certain plants. Animal matter may be contaminated with infection organism unless appropriate precautions are taken. Workers may be exposed to solvents and corrosive chemicals during biological and natural extraction operation. Fire and explosion risks are posed by storing, handling, processing, and recovering flammable liquids. Moving mechanical parts, hot stream, water, surfaces, and workplaces, and high noise levels are risks to worker safety. Water or solvent wet solids are dried during many pharmaceutical manufacturing operations. Dryers have different designs and filters with varying containment and control of vapors and dusts. See these slides. On this slide you can see a rotary vacuum dryer. Flammable solvent vapors and explosive airborne dust may create flammable or explosive atmosphere. Explosion relief venting is particularly important on contained dryers. Dilutions reduce the risk of fire of explosions in addition to controlling worker exposure to solvents vapors, then handling wet cakes, or to airborne dust, then unloading dried products. Heavy material handling may be involved in loading or unloading dryer trays, bins, or containers. Mechanical equipment, it's for example drum jacks, lifts, and work platforms, assist these manual tasks. E-wash and safety shows should be located nearby in case workers accidentally contact solvent and dust. Tablets and capsules are most common oral dosage forms. Compressed or molded tablets contain mixtures of drug substances and excipients. These tablets may be uncoated or coated with solvent mixtures or aqueous solution. Capsules are soft or hard gelatin shells. Tablet presses, you can see on the slides. Tablet coating equipment and capsule filling machines have different designs and features with varying containment and control of mechanical hazards and airborne dusts. Workers may be exposed to spillways vapors when spray coating tablets. Modern tablet coating equipment is highly contained. However, can be installed in older open coating pans to control fugitive solvent vapors. Tablet coating equipment can be vented to air emission devices to control VOCs from the process. you can see on these slides. Tablet coating machines. Whenever possible, recovered solvents should be reset by the process or aqueous mixture substituted for solvent mixtures for tablet coating. Modern tablet process and capsule filling machines are enclosed by interlocked panels, reducing the hazards of fast-moving pads, high noise level, and dust emissions during their operation. Hearing protective devices can be reduced worker noise exposure during capsule and tablet operation. Sterile products are manufactured in pharmaceutical manufacturing plants with modular design, clean workers and equipment services, and high efficiency particulate air filtrated ventilation system. The principles and practice of controlling contamination in sterile liquid manufacturing are similar to those in the microelectronic industry. Laboratory operations in the pharmaceutical industry are diverse. They may pose biological, chemical, and physical hazards depending upon the specific agents, operations, equipment, and work practices employed. Minor distinction exists between labs which conduct scientific research and product or process development, and those which evaluate quality assurance and control activities. Lab workers may conduct scientific research to discover drug substances, develop manufacturing processes for bulk chemical and dosage for products, or analyze raw material, intermediates, and finished products. Lab activities should be evaluated individually. Also, good lab practice applied to many situations. Clearly defined responsibilities, training and information, safe work practices and control measures, and emergency response plans are important means for effectively managing environmental health and safety hazards. The health and safety hazards of flammable and toxic materials are reduced by minimizing their inventories in labs and storing them in separate cabinets. Lab assays and operations which may release air contaminants can be performed in ventilated exhaust fume hoods to protect workers. Worker training and information describes the hazards of the lab, safe work practices, and proper emergency response to fires and spills. Food and beverage should not be consumed in lab areas. Lab safety is enhanced by recurrent supervisions to approve and manage highly hazardous operations. Good lab practice: separate, treat, and dispose of biological and chemical wastes. Physical hazards, like radiation and electromagnetic energy source, are often centralized and operated according to specific regulation. On these slides, you can see the final stage. The drugs are dried, shaded, ampoules, and packaged. The main adverse factor is dust, chemicals, as well as the forced position of the body. The following are examples of process modifications in bulk pharmaceutical production. They are minimize the quantities of hazardous material used and select materials. Those wastes can be controlled, recovered, and recycled whenever possible. Develop and install system for recycling raw materials like solvents, intermediates, wastes, and utility material like cooling water, heat transfer liquids, lubricants, stream condensate. Examine reactants, solvents, and catalysts to optimize the efficiency of chemical reaction. Modify the sink and filters of processing equipment to minimize pollution and wastes. Improve processes to maximize product yields and desired properties. Eliminated additional processing like recrystallization, drying, and milling. Consider using multi-purpose equipment to reduce pollution and wastes during transfer, cleaning, and additional process steps. Use operative instruments, automated control system, and computer programs to maximize the efficiency of processes and reduce pollution and wastes. The main institutions of the pharmacy chain are pharmacies. They are self-supporting pharmacies and pharmacy of medical institutions. Depending on the amount and work, which is determined by the number of recipients and trade turnover, pharmacies are divided into categories. There are 6 categories of self-supporting pharmacies and 5 categories of pharmacy of medical institutions. What is a hygiene of pharmacy institution? Is a section of hygienic science that studies the impact of professional labor in pharmacies on the body and develop hygienic measures aimed at protecting the health of pharmacy workers, increasing efficiency and productivity, and developing measures to create optimal sanitation and hygiene conditions. On this slide, you can see institution of a chemist networks. They are pharmacy manufacturing, drugstores of finished medicines, pharmacies of medical and preventive institutions, pharmacy stores, shops of medical equipment, optic stores, pharmacy database, bases of medical equipment, pharmacy warehouses, and control analytical laboratories. Pharmacy public health institutions. Whose main task is to provide the population and of medical institution medicines, medical supplies, and personal hygiene. The necessary condition for the proper performance of its function, the pharmacy is the great optimum hygiene and sanitary condition of its maintaining and operating. On this slide, you can see categories of pharmacies of treatment and prophylactic institutions. You can see 5 categories, and you can see by volume of work divided pharmacies in general, specialty and clinical hospital, and pharmacies of psychoneurological hospital. And category depends of numbers of beds in the hospital. The land area allocated for the construction of self-supporting pharmacies should be 0.1–0.2 hectares. Percentage of building area pharmacies must be at least 25%. Percentage area of pharmacies of landscaping should be 50%. As a pharmacy is always a danger of air, pharmacy equipment and medicine pollution, but microorganisms, the possibility of allocating the air drag dust, toxic impurities in the gas and vapor, as well as the creation of unfavorable microclimatic conditions. Microbial contamination of the air reaches the pharmacy premises heavily during epidemic outbreaks. This is a high risk of contracting workers' prescription department. There is a close contact patients like bacteria carriers and healthy people. In various areas of pharmacies can greet unfavorable microclimatic conditions. However, you must know that the temperature norm is pharmacy is 20 up to 12, humidity is 60 up to 40 up to 60%, and velocity is 0.1, 0.2 meter per second. On the slide, you can see structure of pharmacies serving the population. Firstly, public service hall, industrial premises like assistant, room of the chemicals, chemist analyst, packaging, washing, sterilizing, distillation room, disinfection room, assistant aseptic premises, service premises, and premises for receiving and processing plant raw materials. Creating a favorable microclimate in pharmacies and clean air ventilation provides a well-organized with the help of natural and mechanical ventilation, which should be provided in all production areas of pharmacies. The room assistant more appropriate to combine exhaust and input ventilation. Workplace of analytical chemists must have adequate ventilation to the motif gravings. Overwasher, bath tubes to the installed suction probes, as well as to equip the general ventilation. The aseptic room needed input ventilation to prevent bacterial contamination of air in pharmacies. Use bactericidal lamp per 1 cube meter at least up to 2.5 watts of and shielded emitters. Employees of pharmacies perform many operations associated with significant air strain, weighing of the analytical balance of small amounts of drugs, titration and cutting tick marks of the burgers, reading recipes, etc. Therefore, great importance is compliance with natural and artificial lighting. Room of service visitors, assistant room, analytical, chemist room, washing, packing, recreational room should have natural lighting. The required ratio of natural lighting in the aseptic and assistance room of pharmacy should be 2%. The lighting coefficient in assistant, aseptic, packing, analytic chemist, and washing rooms is not less than 1 up to 4. Coefficient of natural lighting is 2%, and in the service of visitor rooms, sterilization, restroom, not less than not than 1 to 6. Coefficient of natural lighting is 1%. That's the norm of lighting coefficient in the analysis room, control and analytical laboratories is 1 to 6. The level of artificial illumination of fluorescent lamps in the workplace in a packing or pharmacy warehouses is 500 lux. In the prescription and sales room must be 300 lux. The norm of general illumination on the table in the hall of the analytical control and analytical laboratories is 500 lux. The height of the rooms of the self-supporting pharmacies categories 1st and 2 should be 3.3 meters. The minimum height of rooms in the pharmaceutical warehouses should be 2.2 meters. Drugs and medical items placed on shelves in cabinet according to their physical chemical properties in view of pharmacological activities and toxicity. All the finished dosage forms are placed and installed in the original container with the label out. An indicator of clean air on pharmacies and pharmaceutical institutions is the number of microorganisms in 1 cubic meter of air. Equipment of production facilities and sales areas are subjected to daily cleaning. General cleaning of premises pharmacies should be held not less than 1 time per week. The minimum frequency of washing windows in pharmacies for the year 2 times. Every 90 days is necessary to conduct sanitary days. For floor disinfection in the aseptic room of pharmacies is intended 0.5% solution of chlorine bleach. You can see on this slide hygiene requirements for the maintenance of premises, equipment and inventory of pharmacies. Firstly, pharmacy equipment should have a smooth surface that is resistant to the effects of medicines, detergents and disinfectant. Wet cleaning with disinfectant is carried out daily. General cleaning once a month. Control is carried out by CHE at least 1 time per quarter. But CHE is the Center of Hygiene and Epidemiology. Microbial contaminated check. Firstly is industrial air. Equipment, especially tables for an assistant, a chemist, analyst, and parties for storing medicines, pharmaceutical utensils, scales, mortals, and other items used in the process of making medicines. The hands of personnel engaged in the manufacture of medicines, semi-finished products, raw materials, finished products, distilled water. On the slide, you can see typical laboratory fractional distillation unit used in pharmacies and aqua distillation device. And now I bring to your attention an interesting video materials about how medicine are made. Please, you can see.
I stand before one of the world's largest and most modern pharmaceutical production plants. Together with colleagues in 16 other countries, we produce medicines that are life-changing for millions of people across the globe. This is AstraZeneca. Welcome. To produce medicines, you need a lot of materials. Every day these are brought here by different suppliers. Most of it arrives on trucks. But we also have substances and gases that are brought here in large tank vehicles. Being one of the world's largest producers and suppliers of pharmaceuticals comes with responsibility. The production, distribution, storage and use of incoming materials have to be managed with the greatest care. We follow strict regulations with very high demands on safety, hygiene and quality. It is important for us to work as environmentally friendly as possible, which is why, for example, we have our own highly advanced water treatment plant here in Södertälje. There are a number of hygiene zones within production which need to be respected by everyone in order to ensure the highest quality in everything we produce. As a visitor, you must always wear specific protective clothing for the various hygiene zones. To enter further into production, you need to wear a higher category of protective clothing. There are also sterile zones, and to work there you must have special training and equipment, and the clothing resembles spacesuits. Now let me take you on a short guided tour of our production to show you what we do and how we do it. As you can see, it's spacious here, so if you want to move quickly, a scooter comes handy. This is a high-tech environment, but of course it didn't always look like this. Astra was founded in 1913 in Södertälje, south of Stockholm. To begin with, there were only 10 employees, but the company grew rapidly. The first real success came with the local anesthetic xylocaine in 1948. Losec, the medicine against gastric ulcers, was launched in 1988 and was for several years the most sold pharmaceutical in the world. In 1999, Swedish Astra merged with British Seneca. Let's begin at the beginning, that is with the production of the active substance or the part of the medicine that helps the patients. It's called the API, the active pharmaceutical ingredient. When you manufacture APIs, it's all about starting chemical reactions. Simply put, you pour solvents and chemicals into a large container, a reactor. You mix them and heat them so that they start reacting with each other. When the reaction has finished, you boil off the solvents you no longer require. You cool the remains to form a crystallized sediment called a slurry. The slurry is filtered to get rid of more liquid, forming a crumbly dough. The dough is finally dried into a powder. The powder is then sent on to the next step of the production process called formulation or preparation. In the formulation process, the API powder is mixed with solvents, usually water and ethanol, binding agents and pharmaceutical excipients in a large mixing machine. The moist powder mix is then dried in a fluid bed dryer until it forms tiny dry grains, a few millimeters in diameter only. This can take anything from 3 to 6 hours. When the drying process is complete, more pharmaceutical excipients are added before the grains are brought to the tablet compression machine for shaping into pills. Last but not least, the tablets are coated to disguise flavors and to make them cosmetically pleasing as well as easier for the patient to swallow. Every step throughout the entire supply chain is documented and controlled sampling is carried out on all materials. Tablets are weighed, measured and checked regarding, for instance, color, shape and dissolving qualities. The quality organization does not only work with controls, they also ensure that high quality is built into the manufacturing processes right from the start. When the tablets are ready, it's time for packing. The packing process is highly automated. We pack approximately 10 billion tablets and capsules every year. That means 19,000 capsules a minute, 24/7, 365 days a year. All in all, we produce around 30 different pharmaceuticals for export to around 100 countries around the world. In addition to tablets, we also produce solutions, sprays and freeze-dried products as well as inhalation products. Sweden Operations Distribution Center is an amazing place. There are 450 meters of conveyor belts connecting the influx and outflow of pallets to high bay cranes, packing stations and driverless trucks, so-called HEVs. The finished products are transported to our spacious storage, the high bay. Here the medicine waits to be shipped to markets and patients all over the world. We try to choose as environmentally friendly ways of distribution as possible. For example, we work to change to sea transportation more often instead of air freight.
Hygienic factors or working conditions of pharmacy workers and employers of control and analytical laboratories, the effects of drugs and harmful chemicals, exposure to microclimatic factors, exposure to noise, normally no more than 30 decibels, visual and other voltage, and forced working posture. While working pharmacies are exposed to unfavorable microclimatic conditions, high temperature, dust, aerosols, medicines, toxic gases and vapors, noise, nervous and emotional stress. Pharmacy workers are more prone to acute respiratory infection, influenza, respiratory diseases. This is a consequence of infection during contact with sick visitors. Much more common in pharmacy workers compared with other population recorded allergies, dysbacteriosis in the production of antibiotics, neurosis, the varicose veins. Pharmaceutical workings in the pharmaceutical industry can present specific hazards from particularly potent compounds. The different drugs which are manufactured can give rise to different health effects. For example, allergic reactions. Some drugs can give rise to allergic reaction such as itching and redness of the eyes, running noise, skin rashes, asthma, and occasionally shock due to the allergic reaction. Other names is anaphylaxis. Vitamin deficiency. Workers with repeated exposure to antibiotics experience a change in the number and type of bacteria which are normally 47 present in the intestines, which break down and absorb vitamins in the intestines. Fungal infection. Daily exposure to antibiotics thus can lead to fungal infection of the skin and nails. Additionally, women workers may develop vaginal yeast infections following exposure to antibiotics. Nitroglycerin, commonly used in dynamite, is also the basis of several medicines for heart patients. Nitriles acts on the blood vessels of the body and their effects are felt in several ways. Almost everyone exposed to nitro dust experiences a severe pounding headache, which is caused by the relaxation of the blood vessels within the skull. Nitrates dilate the blood vessels and make blood pressure fall. As a result, dizziness and even fainting may occur. Tranquilizers can be habituating and addictive. In combination with alcohol, they may cause a person to lose consciousness and in high doses can lead to coma and death. Workers producing tranquilizers are at risk of these adverse effects and have found that they pass out over a beer after work. This is a real danger of accident, both in the plant and on the way home. Then workers become drowsy as a result of exposure to tranquilizers and barbiturates. That the maximum perceivable concentrates of streptomycin in the working area is the production of antibiotics is 0.1 milligram per cubic meter. Therefore, 2 times a week is necessary to conduct bacteriological studies of air in the room control and analytical laboratories. Saving health, increased efficiency of pharmacies provides favorable working conditions in order to ensure sanitary regime staff of drugstores pass medical examination in the established procedure. Pharmacists should observe good personal hygiene and safety work in special clothes, medical ground, hat, indoor shoes. It is mandatory to health education in pharmacies by oral, printed, visual, and combined methods. On this slide, you can see what is a control and analytic laboratories. Analysis of drug and pharmaceuticals from pharmacies, pharmacy warehouse, and pharmaceutical companies. Carry out scientific work on the development of new methods for the analysis of drug and pharmaceuticals. Implementation of scientific and methodological guidance of the pharmaceutical work of pharmacies. consulting on drug quality control in pharmacies, advanced training of pharmacy workers, conducting courses, seminars of the development and implementation of methods of physical, chemical, and bacteriological control in pharmacies. In this slide, you can see category. There are 3 categories of control analytical laboratories, and the category dependent on number of performed tests. The structure of the control analytical laboratory. Firstly, is the analytical room for analysis, weight room, physics chemical rooms, preparatory room, and bacteriological department. Sanitary and hygienic rulings for the layout and equipment of the control and analytical laboratory you can see in the slides. Orientation is south and southwest. Insulation mode is natural lighting is 1 B2, B4. Coefficient of natural lighting is 2%. Artificial lighting is fluorescent lamps above work tables. Overall illumination level 500 lux. Supply and exhaust ventilation and foam cupboards are a must. A modern pharmacist is a medical worker, a specialist in the manufacture and sale of pharmaceuticals. Its activity involved in health promotion and prevention. From this perspective, it is impossible to overestimate the role of knowledge in the field of health for the practical work of pharmacist. Pharmacy is one of the health institutions, those main functions, the timely supply of the population and medical institution, medicine, health products, sanitary items, and other medical goods. As their manufacturing and storage must be strict adherence to hygienic regime, so pharmacists must be well versed in matters of hygienic standardization of environmental parameters, and in particular in pharmacies and pharmaceutical companies. He must have a clear understanding of the nature of the action of production factors and diseases which may arise in case of violation of hygienic standards and sanitary regulation in the pharmacy. Together with representatives of the sanitary and epidemiological service, pharmacists should be able to schedule hygienic measures on labor safety and hygiene regime in the pharmacy premises, carry out hygienic assessment of projects pharmacies. Great importance is the knowledge of the rules of personal hygiene, pharmacy workers. Breaking these rules, pharmacy workers may contaminate pharmaceuticals, distilled water, object pharmacy equipment. It is also possible contamination of pharmacy stuff through the air, recipes, various objects in contact with sick people. In the activities of pharmacists has an important place health education, aimed at improving the health culture of the population, the fight against quackery, self-treatment, and prevention of infectious diseases among the population, and its properties were actually today during the pandemic of coronavirus. Pharmacists use the nature of its professional constantly in contact with the treating physicians and doctors of medical and prophylactic profile. This obligates him to be aware of main issues in preventive medicine, environmental protection, and others. And in end of our lesson, of our lecture, I will say about methods of sanitary educational works. Firstly is oral, direct contact with the audience, like lectures, short informational presentation, etc. Performances of radio, television, internet, etc., in which there is no contact with the audience. Printed methods issued by publishers like books, brochures, printed slogans, posters, articles in newspapers and magazines, greeted by medical personnel question and answer board, photo stand, sanitary wall newspaper, handwriting slogans, article for large circulation newspapers. Next method is graphic methods. Natural objects, for example, demonstration of a pageant care item for a child, first aid equipment, instrument, apparatus, etc. Volumetric objects like dummies, models, etc. Plain objects like pictures, diagrams, and posters, and mixed like films, scientific, fiction, documentary, exhibition like stationery and traveling, and presentation. Our lecture, generally our course of lectures, come to an end. Good luck, student. Thank you for attention. Goodbye.